For this example, we are asked to write down the reaction quotient for this chemical reaction, which is the combustion reaction of a propane gas. In order to write down the reaction quotient for this reaction, once again, we need to make sure this chemical reaction is balanced. So now let's take a look. We have 3 carbon on the reactant side and only 1 carbon on the product side. So we should put a 3 in front of CO2 on the product side to balance the number of carbon atoms. Then we take a look at hydrogen. On the left-hand side, we have 8 hydrogen atoms on the left-hand side. And on the product side, we only have 2 hydrogen atoms. So in order to get 8 hydrogen atoms, we need to put a 4 right here. Okay. So now on both sides of the reaction, we have 8 hydrogen atoms. So the only thing that's left is oxygen we need to balance. On the left-hand side, we have 2 oxygen atoms. And on the right-hand side, we have 3 times 2, which is 6 oxygen atoms, plus another 4. So that means that gives you the total number of 10 oxygen atoms on the product side. So we have 2 oxygen atoms and 10. So we should put a 5 in front of O2 to balance the number of oxygen atoms on this reaction. So now this chemical reaction is balanced. We are ready to write down the reaction quotient for the combustion reaction of propane gas. Reaction quotient, the symbol is QC, equal to the concentration of the product, CO2, the stoichiometric coefficient 3, which will go to the power of the molar concentration of CO2, times the concentration of H2O raised to the 4th power, divided by the concentration of the reactant, in this case the propane gas, C3H8, and then this is only to the 1st power times the concentration of O2 raised to the 5th power. That's it. This is the reaction quotient for the combustion reaction of the propane gas.